Torres will chair this panel. Welcome you all in different presentation in the Congress. We have learned that we need to have a more holistic view and think of integrated or integral agriculture. We have to work in cross-disciplinary groups. This is a very complex system, needs different viewpoints, also partnership between the private and the public sector. It's an honor to share this plenary meeting. This is a very interesting topic, a very interesting concern for all of us. I hope we can make progress in order to have a more global view of our problems. Virginia Aparicio, please take the floor. Good morning. I wanted to thank you, Marcelo, for inviting me to share some thoughts and some facts that we are generating in INTA. As we all know, we are in Argentina. We occupy a continental surface area of 2.780 million square kilometers. We here in this graph will see the surface area or surface planted area of the different crops. This is possible because our continental surface has a temperate weathers. I present here some thoughts from the Pope Francis. This is a very old thought from mankind. He refers to degradation of earth and also to the contamination of water, earth, and air. For those of us who are not Catholic, it's interesting to see how somebody that is not part of the agricultural environment thinks. In soil management, we have different tools. When we use these tools, we improve organic matter content and soil organisms in order to have a top quality resource that ensures water and nutrient availability to produce without impacting on the resource, that is having less contaminants in water or in the land. So soil management is the key to keep good quality in the environment. Our national soil program believes that the soil is process that buffers different processes. It is a natural resources that rechanges in the or recaptures in the environment what comes to its surface. The soil distributes pesticides. In Argentina, we use herbicides, and glyphosate is the main herbicides, which represent 75% of the pesticide national market. I thought it was interesting to see the difference. There is an international agency of cancer research. Its role is to rate the molecules based on the feasibility of cancer in human beings. It has 5 different rates, 4 different ratings or classifications. Why something is carcinogenic and why something is potentially carcinogenic and when something is not carcinogenic. This classification is based on scientific literature that has been published. This is a group of expert scientists that have no conflict of interest in doing this classification. What is our place here? Argentina uses 3 pesticides, glyphosates, 2A, 2,4-D of the 2B group, potentially carcinogenic, and atrazine that cannot be classified as carcinogenic. This creates a concern in the community, in the society. So by decree, the National Organization of Agrochemical Research has been created. The CONICET published a report with very interesting conclusions. The first conclusion is that we don't have enough information about the concentration in environmental matrices. And as there is a possibility to increase the use of this tool, it is important to control the quantities, the amounts that appear in the environment, and see what happens with that molecule in animal and plant organisms. Around the same date, another paper is published, and an endocrinologist, an Argentine endocrinologist, discovers that there are heterogeneous effects in glyphosate. This does not mean that it is carcinogenic, but it gives us an indication that it can be harmful if we use it in a massive way. The CONICET said that there was not enough information regarding concentrations in environmental matrices, and so we started to work in what ended up to be a book that has been published in the INTA website. It is free. It is can be publicly accessed. And here we make reference to important processes of the molecules, degradation, absorption, desorption, transportation, and the information showed in this book has been published internationally. This is by Argentine researchers. It's our soil and our molecules, but this has been published abroad. So it was important to reflect globally the information that we gather here, that we collect here. How do we work? We work from the methodological point of view with published methodologies, and in case we need, if we want to make a sweeping of pesticides, we come together with international groups. We meet with international groups. We enter into, in this case, we contacted a group from Castillon in order to make a test in Argentine soils, and this tool has been published and is used currently. Regarding processes, this is with glyphosate, but we had worked with other different. These are absorption processes. We had conducted long-term trials where we compare conventional tillage and no-till. We are talking about soils that has a higher retention of glyphosate as Paraná and Pergamino compared to Manfredi, where retention is not so high. What does this mean? Retention means that the glyphosate is stuck or adheres to the soil, to the surface of the soil, is not ready to be leached. It cannot reach the underground water or groundwater. With a higher pH, the retention is stronger, and we have to take this into consideration because the behavior of the molecule will be different depending on the place it is located. We have, regarding transport, we have published also the results of findings of long-term trials in Manfredi and Pergamino. When we establish the relationship of what happens compared to what we have applied, we don't see much glyphosate. So we decided to fractionate those columns, and we see that glyphosate is retained in the first centimeters of the soil. And that retention is reduced as we go further deep. What is happening with this molecule is that they cause erosion in the surface part of the soil, and it does not go to another destination, environmental destination. Regarding the trials that we conducted in Paraná, Pergamino, and Manfredi, they have accelerated rate of glyphosate elimination, and 60 days later in Paraná and Pergamino only 50% is left of what we have applied, and in Manfredi only 20%. When we see what happens with the generation of metabolite, we see that at the beginning this does not happen, and in Paraná and Pergamino generates only 14% of AMPA. Here we take into account particles of the soil, the pores in between the particles. Here we have a small arrow, and this means that we have a dynamic equilibrium or balance. When we study the environment, we are analyzing the water table, the soil. The first paper that we published was in 2013. We worked with CREA farmers that have a robust database that include plot management, rainfall data. We considered water, particulate matter, and sediment. Here we can see the detection perception for the different matrices, and in the bars we see the concentration ranges. In the soil it appears in 100% of cases. In sediments and particulate matter, what comes out from the first centimeters, it's appearing in the streams. But you don't see it in the water itself, in the drinking water. Another trial we conducted at the banks of the Quequén River. We consider the soil profile regarding glyphosate before application and after application. Why before application? Because concentration lasts for 60 days. It remains in the soil and it accumulates, and when it is broken down or degraded, there we can consider the AMPA. In this chart we can see glyphosate and AMPA for the long-term trials in the INTA, Paraná, Pergamino, Marcos Suárez, and Barcarce. And instead of fractionating from 0 to 5, we fractionate from 0 to 2 and from 2 to 3. From 0 to 2, there is a higher concentration than in the next fraction. People who work in aeration, wind erosion, take into account the 2 first centimeters of soils in order to check what the content is and how it develops. This is a surface water trial of 4 basins in the country. Here we see that for all pesticides except glyphosate, atrazine appears in all the basins: Tucumán, Misiones, Southeast Buenos Aires. Here we are considering a small basin next to or near the Balcarce experimental station, the space and time variation of pesticides. What we see here, very small, are the months throughout a year and the variation and concentrations of a high point, and in the lower point this was natural with no pesticide, but it gets to the stream. The application of pesticides reach environments where we don't make any application. This is La Suiza colony, or Colonia La Suiza, near Loberia. These people live in the farms, and we are conducting here a social study, but we also are considering what happens with the drinking water they consume. Some farmers have found glyphosate content in the water they consume, and sometimes this content goes beyond the threshold accepted by the European Union, which we don't have in Argentina.
We see that as the sampling of sediment is taking higher in the profile, things and numbers change. When we get to some surface areas, we see that the particulates in small number of microns are not filtrated by our breathing system. This is Santiago del Estero consumption water. In wells, we worked in Banderas and another area in the same province. These are urban and peri-urban. These are the detections that we could measure in those water samples: atrazine, metolachlor, and all the others you have in the list. We order that by average concentration, and we found that glyphosate has the higher concentration average. Therefore, in summary, we are working in this project, and we see that water for consumption in Santiago del Estero, we find it is enriched with plaguicides. We see that there is some glyphosate in other basins in the country. We see that the molecules come in the samples. We are measuring different molecules, not only glyphosate and AMPA, we are also measuring in underground water. So if we go back to the beginning and we think that weather and soil make our country apt to produce raw material and fibers, the concept of efficiency is something really printed in the minds of farmers. We know that we have to use nutrients, but we don't use this concept when we think about plaguicides. We apply too much. Here you have a FAO graph where you have herbicides used in different countries. This is information we provide FAO. You can check this information and you can see that Argentina is one of the countries that after Chile applies the most herbicides. If we compare that with the World Bank graph, we compare how much we produce in terms or compared to the amount of herbicide we apply, and you will see that the ratio is not good. So we have a lot to work on. There are many ag practices that can be implemented. We have a very big area under no-till. So we have a chance here, we have an opportunity to make a better bet on our production, to produce and to be in good terms with the environment. So the conclusion from our group is that we have to reduce the application of plaguicides in the environment, because our big natural reactor is not able to degrade all the product that we are applying. The scientific and technological system has to debate and has to bring more evidence to this debate. That's why I thank so much the invitation to be here. We have many tools, many professional tools to enhance our crop rotation, to adopt process technologies, tillage systems, no-till systems. So we have a lot to work with, and we have to be more professional in what we do. The agronomist has to have a more balanced vision. We are producing in an environment and for a certain community, and that has to be the background for any decision we make. Thank you. Now we invite Dr. Montoya, Jorgelina Montoya.
Hola, buenos días.
Good morning. I'd like to thank the opportunity and the invitation to share with you these significant matters in line with Virginia's presentation. I'm going to explain. I come from the INTA research station in INGLÉS, and I work on agrochemicals as a source of diffuse contamination. I've been working since 2013, and the goal is to understand, prevent, and correct environmental conflicts and recover the deterioration produced by agrochemicals in extensive and intensive production system in order to contribute to our environmental resilience. This project started and is distributed in different modules. Some do training and education, some others do research. Our goal is to get more knowledge. When I say diffuse contamination, that's the name of the project, we mean the involvement of farming, that is the involvement of farming in the environment, that is the agrochemicals applied in large areas frequently at different rates, but it's difficult to identify the first source because each farmer contributes something, and we have different leaks, or the plaguicides or herbicides, the pesticides leak somewhere. The goal is to make them reach the pest or the weed, and the goal would be to have it disappear from the environment, to dissipate from the environment, but that is not what happens. We know that farming basically focuses on producing food. However, in recent times, the community sees farming as a way to contaminate the environment. So why do we do all this research? What is the goal? Pesticides are exogenous substances with certain toxicity. First and foremost, we have to understand the deterioration, if any, of the environment, and based on that information start resorting to different practices in order to reduce the negative impact. This information is produced by science and technology and is provided to establish environmental and public policies that will support a sustainable production. A pesticide, after its application on the environment, on the soil, well, part of it can be retained by the soil. You see here a word that means that this is kind of stuck to the soil. Another part can be decomposed, another one can be photodecomposed, others can be volatilized, part can be taken by the crop or by the weeds. But I'd like to focus, since that is the goal of this presentation, on the role played by the absorption and degradation processes. Those are the two areas I will focus on. These are the main processes that regulate the availability of pesticide in the soil. I will focus on herbicides because my work is on weeds. We have a competence rate here between absorption, retention, and biodegradation, or product availability in the soil. Absorption depends upon the soil, the moisture content, and the temperature, and basically the kind of molecule that I am applying. Biodegradation, on the other hand, depends upon the amount that was retained, the type of soil, more or less content or organic matter, the presence of microorganisms, which is really significant because they are responsible for degradation, humidity or moisture, and temperature. If we have a high absorption, well, that limits biodegradation. We can see here in this slide the relationship with the molecule. Not all molecules behave the same way. We may say that depending upon the chemical nature, molecules can be more or less retained by the soil and can be more or less degraded because they have more or less resistance. And of course, this is related to weed management because some molecules are residual in nature. We have to consider water solubility, volatility, and also the formulation, the concentration, the application, the moment, the time when we apply the rate, which is a great element, a great component of all this issue. We have to consider topography, soil texture, microbial population, other pesticides, because there are synergies, whether the soil has been applied to different application or spraying technologies, and of course weather, temperature, sunlight, rainfall, humidity. All of this affect degradation. In humid, warm climates, degradation will be faster than in areas where temperatures are lower, because of course this affects the organisms and the bacteria that are so much involved in degradation. And of course we also have to include as a component carryover. Chemical composition of herbicides, let me just say that there's a relationship. If herbicides are neuter, anionic or cationic, because this affects availability. That is also related to pH. Soils can react to cationic changes, so when we apply a herbicide in an anionic condition, it will not be retained. It will lixivate, it will bleach. A neutral molecule can be retained much easier, basically by organic matter. And if we go to soil pH values, cationic in nature, they can be retained much more. This is something that affects the availability of the product, that is subject either to degradation or bleaching. If I go to some of the most widely used herbicides and we check their behavior on the soil, we see here weak acids that relate to soil pH. They can be anionic and they can bleach very easily. And then we have the family of imidazolinones, glyphosate, which is in the soil in an anionic state, and it has a high capacity of being retained by soil. When it reaches the soil, he becomes friend with the soil, and it can be retained by iron and aluminium. So when there's dust on the surface, the weeds inactivate that. We have here the sulfonylurias. This is a molecule with a neutral behavior. Then we have the triazines. Atrazine is one model. This is a weak basis. We have polar non-ionic components, and paraquat, which is a cationic. It touches the soil and is immediately and strongly retained. We see that part of this will be retained and another part will be bioavailable, and we will control weeds. It is also subject to microbial or chemical degradation. If there's moisture in the soil, it can bleach. That means losses along the soil profile. There is runoff. That is very much related to how we manage the soil. If agricultural practices are not consistent with the soil nature, runoff happens. Runoff can be in suspension, or the herbicide can be diluted in water. This is a difficult slide, but I wanted to show you the list. The first table, this is a monitoring that we've been carrying out for 5 years. The aquifer here is vulnerable. These are permeable soils with sandy, loamy texture, with water tables that, depending on rainfall, go from 2 to 6 meters deep. The first table, the one on the right, shows the quantification that we've been measuring in wells and in mills. We have monitored 3 molecules. One is an ionic molecule, a neutral, atrazine, and glyphosate, particulate glyphosate, which can be retained by the soil so much. The concentrations, the first is neoazapine. You cannot see the concentration, but this is a very high concentration, closely related to the low absorption capacity, 0.5, 0.3. Atrazine can be 4, 9, 8, depending on the soil. Those are the values, the absorption rates. And glyphosate, it can be 500, 600, 1,000. So from 0.4 to 1,000. Very high concentrations. Atrazine, it's the same monitoring, and you see the presence, the different values that relate to the absorption and the lower persistence. And the concentrations we find are similar to those we also find in other areas of the country. So what am I showing with these 2 lines? This is not diffuse contamination, but considering these very high concentrations that we have found in these molecule samples, in this tank or in this mill, this means very bad management. We have to improve this. These are the windmills that have the better quality water, low alkalinity, not hard water. So we are ruining, or we are damaging a well because we are leaving the empty containers like this. We also saw that there was a higher frequency of products found in the monitoring. This is in line with this imazapine, atrazine, and you see the water table that is raising. So you have water on the surface, and this water finds a high concentration. There's dilution, and then we find the product in the water table. AMPA and glyphosate, AMPA and glyphosate, the monitoring has not been going on for so long. This is 2010, and this relates to glyphosate capability to reach underground water because it is absorbed so easily. We have here preferential flags or bleaching unless the soil is saturated. That is probably why glyphosate was found here. Now I'd like to go a bit more into detail into management practices. We created this drastic index that shows aquifers vulnerability in the province of La Pampa that is shown on the map next to Argentina's map. We see the recharge in this province March, April, and November, and we see that the aquifer vulnerability is reduced from east to west, different quality waters, and the graph on the right shows the monitoring that we did. We checked atrazine, glyphosate, AMPA, and we saw that the yellow area, the less vulnerable area, there were less residues of pesticides in underground waters. In the more vulnerable area, there were higher concentrations. We checked how much input was used in those fields, except for atrazine, which is a very old molecule farmers have used for many years. We see that except atrazine, glyphosate, and AMPA, when inputs are low, frequency is also low. So this leads us to think that we should use pesticides in a reasonable way. Part of the project is find technologies to mitigate the use of pesticides. One of the technologies that has been widely explained in this conference is the use of cover crops. So we have suppressed the fall-winter weeds with cover crops, and we have reduced residual pesticides applications.
Here we see how Conaisa appears in the wheat. The other are cover crops, and the corn yield were the best with veg or veg plus triticale. We can see here we see what happens with cover crops. That had a different management, but the important thing here was the fallow management. So we didn't need to use residual herbicides as in the chemical fallow that we used atrazine. As part of our trials network, we didn't use glyphosate to burn or to interrupt cover crops. And we are using this role that probably you are acquainted with. We also have a sampling network. I'm part of this project. This project included the participation of different groups, farmers' chambers, cooperatives, farmers. They conducted a sampling of surface water. The samples have 8 100 parts per million, below 300 parts per minute, which would be the minimum for human consumption, we had about 96%. And those concentrations were found in waterways. This a consensus which reached with farmers. Glyphosate appeared. We have runoff plots. We know that in these loamy soils, we found that crop rotation, corn, soybean, wheat, soybean, cover crops, and wheat, we can say that the water runoff is much lower, so we reached the conclusion that it is important to have crop rotations. In these plots with monoculture, more water was lost than in plots where rotations were implemented. Based on this and with all these monitoring activities, we established guidelines that will help us achieve what we are targeting at, which is crop rotation. Try to work with rainfalls, try to spray, to leave buffer zones around waterways, so the spraying does not impact on the waterway. Engineer Sassali and her Paraná group of collaborators showed the competition. We all know the competition between grass with glyphosate, where in absorption sites where phosphate is stronger than glyphosate. I apologize because I used more time. Thank you, Jorgelina. We don't have much time for questions. This invites us to work in networks, to learn how to work together. I think that science and dialogue will help us make progress along these lines. Improve the dialogue capacity will help us. Let's go to questions. Virginia Aparicio. Are you measuring impact of molecules of ALS herbicides? I work in the soil and we measure molecules in the soil. Environmental impact, we are not measuring environmental impact. We sometimes measure environmental impact of the more concerning molecules. What happens with the international thresholds? You know that Argentina does not have thresholds. The activity that was developed by Carolina Socho in Paraná is very interesting because people started to think or consider the threshold. We don't have thresholds, so we consider international thresholds. And if we are going to use such a stringent threshold as the European Union, we are exceeding that threshold. The European Union states or sets 0.1 ppm. And this is a very low threshold. So in general, we are exceeding that threshold. Our problem is the health of people. I think that it is a good thing to have a stringent threshold. Toxicologically, are residual toxins more concerning? No, toxicology has nothing to do with the persistent or with the absorption. It's something else. We can be concerned with the fact that the residual herbicides by itself, to have this residual action, a fraction has to be available in the soil solution. But toxicology is not related to that. I wanted to compare the European Union sets a detection level that can be developed from the analytical point of view. Shall we read the question again? What are the residue tolerance between the European Union Commission and other countries? The European Union has a tolerance per molecule, atrazine 3 micrograms per liter. The European Union Commission establishes the level of detections, and we know that applications are either atrazine or glyphosate. What we are applying in agriculture are cocktails, mixtures. So I personally believe that it is better to set a maximum threshold for all the molecules, regardless of the toxicology, because what we have not analyzed are combinations. Let's consider pure water in Europe, and others worked more in the combination of molecules. That is the difference. As you said, we have to establish thresholds and combine this with agronomical practices. I apologize that you have to make such a short presentation, so I hope that next time you have more time to expand.